Hello everyone, and thank you for joining us for this fourth installment in our webinar series, Optimizing Drying Conditions. Again, my name is Brandon Burton, the Technical Director for Restoration Sciences Academy, and I want to start by thank you for joining us today. We're going to start off with a quick review on balancing drying systems, a part of our webinar and the second in our installment, because today's discussion in understanding how to optimize drying condition relies on a lot of the foundational information we covered in that presentation. We're then going to take that information and further expand that specifically into sizing and controlling dehumidification equipment. There are some very basic factors that we need to understand in appropriately sizing equipment initially for the job. However, there are several common problems that can occur because every job is highly unique and extremely different. And we'll cover a lot of those topics as we go and understand how to problem solve and identify those errors or problems so that we can ensure we have the appropriate and adequate drying environment throughout the drying project. So again, thank you for joining us today, and let's begin with just a little bit of review. As we discussed in an earlier webinar, understanding how to balance the drying system requires control and an understanding of three different components of how we manipulate the air to support evaporation. These include airflow, temperature, and humidity. In our previous discussions, we understood that the velocity of air movement along the wet evaporating surface was important, but so was the temperature of the water we were trying to evaporate. And finally, the amount of water already in the air above or around the wet surface also had an influence on the rate of evaporation. We further took this information and evaluated this against known drying formulas. The formula on screen isn't something that we did or will go over in detail. However, there are some very important components of this formula that are critical for any professional restoration contractor to understand. And that is, in very simple terms, that the greater the velocity of air in this formula, the greater the rate of evaporation. The greater the water's temperature in this formula, the greater the rate of evaporation. And finally, the lower the humidity in the surrounding air, the greater the rate of evaporation. With these factors considered, we understood that the velocity of air was actually a multiplier in the evaporation rate. It's one of the most influential factors in the process. When we take a look at the water temperature and the humidity of the air, it creates a differential where we see x minus x in the calculation. The greater the difference between these two components, the greater the potential evaporation rate. We discussed this as being a vapor pressure difference. Taking this information and applying that to the timeline in a water damage environment, it also helped us understand how to manipulate the balance between humidity, airflow, and temperature at different stages in the drying process. Initially, when we begin drying, we're tackling something called surface water, the easy water immediately available at the surface of the material. And in this particular portion of the drying process, air movement was by far the greatest factor in the influence over evaporation. This is the reason why we spent so much time on it in the first two webinars. However, as we move away from the easy surface water, and we get into the liquid water inside materials, something we call free water, the impact of airflow began to diminish. This is because the movement of air was no longer in direct contact with the evaporating water. However, because liquid water is still present in materials, a high humidity, called a boundary layer, must still be removed from the surface. As we move past the free water stage and finally into the difficult, deeply bound water within most building materials, we found that air movement had a very diminished impact, almost no impact, but yet still important. What became ever increasingly important was a focus on low humidity or low vapor pressure in the air and ensuring that building materials and the water they were holding were of an appropriate warm temperature. These adjustments help us ensure to maximize our drying rate as we move through the drying process. Finally, in our last webinar, we then took a look at the overall monitoring and decision-making process and understood that there were 4 questions that we were trying to ask and answer, so we understood what direction and progress was being made on the project. That was understanding initially what was wet within the building, identifying water migration, identifying the material types, so we knew what we were targeting. Then, once we decided if we were or were not going to dry the materials, we had to define how wet the materials were that were going to be restored. This was critical because the third question on the left-hand side, is it drying, cannot be answered without first understanding where we were starting from. And then finally, ultimately, we needed the ability to understand whether or not the project was completely dried at the fruition of the restoration effort. Within this process, however, the component we're going to focus on today is specifically around sizing dehumidification equipment to the restoration project, then solving problems related to that dehumidification to ensure that we have an appropriate drying environment. This table in the middle of this process expresses the amount of dehumidification required in liters per cubic meter of the area being dried. In other words, in some environments, we need more dehumidification, and in other environments, we need less. The factors that determine how much dehumidification are required are multiple-fold. First and most importantly, we have to understand the volume of air that we're attempting to dehumidify. The greater this volume of air, the more difficult it is to control the temperature and humidity within a space. Obviously, in other words, much larger buildings require more resources to control temperature and humidity than smaller structures and buildings. Secondarily, however, even if the volume of air is identical between two projects, that does not necessarily mean that the amount of dehumidification required is also the same. The next factor we have to consider is abbreviated on this table as S, M, and L, meaning small, medium, and large scope. In other words, if in a given space or room the amount of damp or moisture is minimal, then the amount of dehumidification will also be minimal. However, if entire surfaces, such as an entire floor, are damp, then more humidity control would be needed. And finally, if multiple surfaces, including floors and walls and ceilings, are all affected, even more humidity control would be required. Finally, the final consideration for the amount of humidity control required is the type of dehumidification that will be used. There are three predominant dehumidification technologies that are used in our industry today. They are the standard or conventional refrigerant dehumidifier, the newer low humidity refrigerant dehumidifier, and the desiccant dehumidifier. Depending on the technology chosen, the amount of dehumidification resource will also change. For example, using an older technology standard refrigerant will require more dehumidifications on site than using newer, more efficient low humidity refrigerants, because the technology is simply more efficient. With that information considered, there are 4 steps in sizing dehumidification to a restoration project. The first step, typically, is determining the exact volume of air to be dehumidified in cubic meters. We'll cover that in just a moment. Secondarily, we then need to take a look at the space and understand the scope of damp within the environment. How much is really affected and how much water is really present. Describing these very generally, a small scope would be partial wetting of an area. For example, only 20 or 30% of a floor and a very small portion of wall assemblies are affected within that entire space. In a medium scope, we're looking at an entire floor that is highly damp. In a large scope, we are looking at floor and walls and/or ceiling that are also affected. Understanding the scope is critical to properly sizing dehumidification to the project, because it's the amount of evaporation, ultimately, that determines the amount of dehumidification needed. And obviously, in a room with substantially more wet surface, we're going to have more evaporation within that same environment. Once we've determined the scope, we then need to choose the appropriate dehumidification type. Choosing the dehumidifier type is reliant upon a number of factors that we're going to cover in a later webinar. However, for a brief overview, generally speaking, we're going to use low humidity refrigerants or desiccant dehumidifiers as a best choice in most projects, and standard refrigerant dehumidifiers ultimately when that's the choice we have available based on our equipment resources that we have available to the project. Low humidity refrigerants will always provide the greatest energy efficiency in virtually any restoration project, and desiccant dehumidifiers provide a unique opportunity in particular situations when we're dealing with certain drying challenges. Again, we'll cover this in greater detail in a later webinar in our series. Calculating for the cubic meters of a space requires that you look at the entire airspace that will be dehumidified. A common misconception when sizing dehumidification to a restoration project is that the air only needs to be calculated over the wet surface, and this is a significant error. The dehumidifier will be processing all of the air within the space that is open to your drying environment. For example, if you're drying a bedroom and the bedroom door can be closed, then we only need to calculate for the air within that bedroom. However, if we're drying a bedroom, a hallway, and an adjacent bathroom, regardless of the percentage of those areas that are affected, if all of those spaces will be open to one another, then we must calculate for the total air volume in all of those spaces, because the dehumidifier must treat all of that air. In really simple calculation, if we were drying an entire building that measured 7 meters by 3 meters by 2.5 meters tall for its ceiling, then that calculation would give us a total of 52.5 cubic meters. That's simply multiplying the length by the width by the height. Second, we would then determine the scope within the structure. Let's say that in this particular scenario, generally the entire floor has been affected and it is highly damp. However, we're only dealing with several centimeters of wicking of moisture or damp in the wall assemblies. So predominantly, we're just dealing with the floor surface. This would be a good description of a medium scope. Third, we would need to choose our dehumidification type. And for the sake of this example, let's say that we've chosen to use a low humidity refrigerant dehumidifier. Calculating for dehumidifier sizing would then follow this logic. We would multiply for our cubic meters, 52.5, then use the scope and the dehumidifier type on this table to determine a factor. This factor represents the liters per cubic meter required for dehumidification within the space. For a medium scope and a low humidity refrigerant, that factor is 2. In other words, we need 2 liters of dehumidification at an AHEM 24-hour rating for every cubic meter of air that we will be dehumidifying. So in simple terms, we take our cubic meters and multiply by that factor. We need 105 liters of dehumidification in this space. Now it's important to understand how dehumidifiers are rated so that we can appropriately apply this 105 liter number. It's important to look at the specifications that are published by manufacturers and seek out the AHEM stated rating for the dehumidifier. AHEM is the Association of Home Appliance Manufacturers. They're a third party that rates dehumidification at a fixed condition of 26.7 degrees centigrade and 60% relative humidity. Notice on this particular page that there are more than one water removal rates published for this particular dehumidifier. We have a max removal rate of 91 liters per day, and we have an AHEM water removal rate of 58 liters per day. The realistic and important number is the AHEM number. The maximum number at 91 is a significantly overstated rate of performance used by virtually every manufacturer in the industry. This performance number is the water removal at 32 degrees or higher and 90% relative humidity. In these conditions, this dehumidifier will produce 91 liters per day. However, as a restoration contractor, you should never allow an environment to be above 60% relative humidity for any substantial period of time. In other words, you'll never realize 91 liters a day. And if you do, it's because you have an extremely humid environment that is suffering secondary damage. This is not a drying environment, that is a wetting environment. So the realistic number is the AHEM number, and the calculations we just reviewed are based on that AHEM number. Now the number was 105 pints required for the project. This particular dehumidifier removes 58 liters per day. At 58 liters, 2 of this dehumidifier would be required for the project. 105 liters, single dehumidifier at 58 liters, not enough. 2 of them would give us 116 and would exceed that minimum requirement. Once the dehumidification has been installed, however, there are several common problems that can occur with humidity control. It's important to understand, in other words, that every job is highly unique and very different, and they will pose challenges and unforeseen variables that cannot be quantified necessarily during our initial visit to the project. So now let's spend some time understanding what these common problems are and what the resolutions are to some of these issues and problems. To get to that point, however, let's first understand in general how we evaluate if there is a humidity control problem. And to understand this, I'd like to share with you an analogy using a bucket or a small container. And on this bucket or container, we have two pipes connected to the container. One allowing moisture to flow into the container, the other removing water or moisture from the container. Let's call the flow into the container evaporation and the flow out dehumidification, and the container the building you're drying. Over time, as evaporation occurs within the space, that evaporation is going to add moisture into the air within the environment. With no humidity control, obviously over time the humidity would build and increase. However, with dehumidification, as long as that's at an appropriate rate, water will remain at a fixed level within the environment. In other words, a fixed humidity. In short, if the flow rate evaporation into the air within the space is equal to the flow rate out of the space, then humidity will remain exactly the same over time. However, in many circumstances, for whatever reason, the flow rate of water into the space and the flow rate of water out of the space are not equal. And let's say, for the sake of argument, that water is evaporating into the air at a faster rate than dehumidification is removing it from that same air. The consequence is that humidity will increase over time. The challenge with making this assessment, however, is that in many cases the wrong measure of humidity is evaluated. The relative humidity within the environment can indicate problems, but fluctuation in relative humidity, unfortunately, is not necessarily a direct reflection of the amount of moisture within that air. It's important that we instead look at a humidity ratio or a specific humidity, something referred to as grams per kilogram of dry air. If this phrase is not 100% familiar to you, again, I'll encourage you to attend some of our future webinars where we'll address that topic. For now, however, we'll leave it simple and state that we must evaluate the humidity within the environment over time. And if the humidity is increasing as a trend, then the rate of evaporation is exceeding our rate of dehumidification. Now, obviously, there's one simple way to fix or remedy this problem, and that is to manipulate the rate of dehumidification. If we increase the rate of dehumidification to a point at which it is greater than the rate of evaporation, then humidity will decrease over time. And as simple as this sounds, it's unfortunately most commonly not the appropriate fix to this challenge, which is the point of this discussion. In most cases, when we respond to a drying environment and we see excessively high humidities, the first initial reaction of virtually every restoration professional is to simply install additional dehumidification to deal with the problem or deal with the issue. However, without first performing a better analysis of what's causing the problem, this can lead to disastrous results. Now, looking at this on a chronological timeline in a drying environment, generally when equipment is first installed within the space, humidity is going to increase. If you remember from our earlier discussions, this is because we're tackling the easy water, the surface water, and this water evaporates at a very high rate. As that water evaporates, humidity will build. However, this spike in humidity, as it's commonly referred to, should be very short in duration. If things like the water extraction and other preparation and mitigation tasks are performed properly, this spike should be shorter than 1 to 2 hours in period of time. If throughout the entire duration of the initial setup the humidity continues to build, and after 2, 3, or 4 hours of project setup the humidity is continuing to build, this is an indicator that there's a much larger problem than just a simple humidity spike at the front of the project, and an adjustment must be made. The adjustment we'll discuss in just a moment, but that adjustment is manipulating the balance between evaporation and dehumidification. An appropriate adjustment is going to have a very obvious end result. The humidity within the space is going to begin to decrease over time. However, Just because the humidity begins to decrease does not necessarily indicate that we have utilized or installed the most appropriate adjustment for that environment. Let me explain. There are two reasons or two areas that are going to cause humidity to be increasing at an uncontrolled rate. That uncontrolled increase over time can be due to excessive evaporation, or it can be due to deficient dehumidification. Because most restorers automatically look at the dehumidification side and add dehumidification to address the problem, let's not look at that first. Let's look at excessive evaporation. Let's say, for example, that the reason why there is a humidity increase over time is because the extraction process, the vacuuming and evacuation of liquid water out of the building, failed. In other words, there are textiles within the environment that are still excessively damp, or there are trapped pockets of liquid standing water within spaces and voids within the structure. If this is the reason why humidity is increasing so rapidly, adding additional dehumidification will not fix this problem. It'll simply eradicate the symptom of this problem in the environment, and will still lead to excessively long dry times and potentially damages from the excess moisture being present for so long in the environment. Let's say that there are wet areas within the space that were never discovered. For example, there may have been multiple water sources. If a frozen pipe or some other type of weather-driven event caused the water intrusion initially, then it's quite possible there may be wet areas that were not discovered during the initial inspection. If this is the reason for an excessive humidity that your dehumidification is not controlling, then again, the addition of additional dehumidification is not the appropriate solution. The appropriate solution is to address the excess water through proper extraction, proper mitigation, and then recalculating for the size of dehumidification needed based on the new discovery for the number of wet areas, rooms, and spaces, and the scope of damp. Another reason for excessive humidity may be because of an additional water source of some type, such as infiltration. Especially when dealing with water damages throughout the summer period, outdoor humidities can be excessively higher than our target indoor humidities. Depending upon the age of the structure and the type of mechanical systems like heating and ventilation systems, there may be additional moisture being brought into the structure by the outdoor environment or via the outdoor environment. This can also be occurring because of the manipulation of doors and windows by occupants when you're not present. And if this is not properly understood by occupants, then regardless of the amount of dehumidification installed, if we're letting excess moisture in from the outdoor environment unchallenged, then no amount of dehumidification is going to give you an appropriate drying system. Then finally, what about a recurring intrusion? If the water source has been not properly addressed and additional water is leaking into the building, then again, no amount of dehumidification is going to address this problem. In many cases and in many restoration projects, one of these four can very likely be the cause of your excessive humidity within the environment. It's critical as a restorer to make an appropriate assessment as to whether or not one of these truly is the cause of the high humidity that you're dealing with within the space. After and only after these have been considered, then move to the dehumidification side of the consideration. Now on the dehumidification side, it could be that you've installed an inadequate quantity of dehumidification. To understand whether or not this is the cause of high humidity and adding a dehu is the right fix, simply revisit the math that we just discussed. Ensure that you properly calculated for your cubic meters. Ensure you've properly described the scope of damp. And then at the end, as an end result rather, ensure you've selected the appropriate factor and done the appropriate math to size dehumidification. If you've done this math properly, this should not be the reason for your high humidity within the space. Secondarily, inspect the dehumidifier itself and ensure it doesn't have any major mechanical problems. One of the major causes for a high humidity spike, in other words, is not that you haven't installed enough dehumidification, but the dehumidification you've installed is not performing to spec. The common causes for this are inappropriate filter management, coil systems that have not been cleaned for a good number of years. Now, these are inspections that should be performed on a regular basis on dehumidification equipment. As dehumidifiers run within restoration environments, they tend to collect a lot of dust and debris, filters begin to load, and worse yet, the coil systems internally begin to load with dust and debris and can in some cases even begin to oxidize. In these cases, the coil systems need to be properly cleaned so the dehumidifier is again performing to spec. Simple inspection: does the filter look physically loaded, and does the coil system look like the bright aluminum color to which it's supposed to appear? If either of these are not true, then it may be that the dehumidifier is simply not giving you the 58 liters per day that you expected to get when it was performing to spec. Third, look at the dehumidifier's hour meter. Has the dehumidifier been operating consistently throughout the entire period after it was installed? Very commonly, the reason for a high humidity or an unexpected high humidity in a space is because the dehumidifier has only been operating intermittently. This may be because rather that occupants have been turning off the equipment for periods of time. If this is the cause, then unfortunately, adding another dehumidifier to the project is simply going to give the occupant another power button to push when you're not there. And it may sound a bit silly, but it's quite truthful, that if this is the issue, then the only proper remedy is educating the customer to some degree, or the occupant, to try to eliminate the intermittent operation of the dehumidifier. In some cases, the intermittent operation, however, has nothing to do directly with the occupants, and it may be just the power system within the building. You may have utilized the power in such a way that the power is throwing breakers, that the power in the structure itself is too old and no longer to spec and not reliable. And in these cases, if that's the reason for the failure, most dehumidifiers of a newer type are going to give you information to help you understand that the power failure has been occurring. If this is the reason or the cause, then consider bringing in temporary power distribution and running clean power through a licensed or appropriately qualified electrician to run the dehumidifier off of a power source that we know we can rely upon. Now, these 8 items, all separate and very unique, most commonly are not considered by restoration contractors when they see a high humidity spike. However, this provides a very powerful checklist for you to ensure that we're properly identifying the core problems that are truly causing the high humidity within the space. Without this process or this checklist, it's very easy to misappropriately apply a solution when the problem itself is not being addressed. Much like going to the doctor's office or to a physician and complaining about a headache and getting a prescription for a painkiller, when in reality there's a much larger underlying issue. Much as a physician, as a restoration contractor, it's critical that we apply the right filter to get the right information so that we ensure we're applying the right solution to the issue or to the problem. In other words, the adjustments that are not based on these true core problems are not going to prevent additional damage from moisture in that environment. Only the core problem being addressed is going to prevent the damage that core problem is going to create. So these are some methods in understanding how to apply the appropriate solutions when we're running into challenges with the humidity control within the space. Just as a recap on this discussion, if the issue is, for example, undiscovered water within the environment, adding dehumidification into the environment is simply going to mask the symptom of that problem. It's not going to address the true core underlying problem. Only discovering that moisture, extracting that moisture, including that in the scope that I'm putting onto the project, and then ultimately sizing humidity control to now include that scope is going to give me the appropriate solution to restore the environment, eliminate potential damages, dry the structure in a rapid period of time, and deliver at the end of the day the quality product for my customer that we're trying to target. So this is optimizing drying conditions. The information contained within this webinar will be posted onto our website here in the next couple of days. So I encourage you to take what we've gone through as our discussion today, share this information with others in your organization. In addition to this webinar, we now do have recorded versions of the previous webinars that we've shared, the first 3 in our 10-part series. And I encourage you to go back into the DryEase, dri-eaz.uk.com website and follow the links over to the RSA online webinars. You'll notice there on the website that we've posted a full schedule of all of the upcoming webinars, and on the right hand side we've posted all of the completed webinars and the recorded version of those webinars. The videos are all there. The very first webinar, The Importance of Airflow, now even includes a full white paper to go along with the video. The white paper is a great training document. It contains all of the information that we contained within that webinar, plus a tremendous amount of background information to support all of the scientific information we presented during that webinar. Makes a great handout for training purposes within your organization, and we highly encourage that you use it for that purpose. If as you go through that information, there's anything that I can do for you, please do not hesitate to contact me. I'll back up a couple screens here. My email address is brandonb@rsa-hq.com. You can also contact Colin or Ann over at our Dry-Ease UK office for any of your technical needs. We're more than happy to give you a hand and to help you. So moving on to our next webinar, our fifth webinar in our series. We hope that we see you for that. We're going to begin to transition into an overview as we move into the next webinar of everything we've covered up to date to give it a nice finished wrapper for the first 4 subjects. And then from there, we're going to start moving into some of the more advanced techniques in restoration as we move into the second half of our 10-part series. So again, thank you for joining us. I appreciate you spending the time with us this afternoon. And I look forward to speaking with you again at the very longest a month from now in our next webinar. But don't hesitate to reach out to me if I can help you between now and then. So thank you again. This is Brandon Burton with the Restoration Sciences Academy, and I look forward to our next opportunity to present you with our technical series.